Okay, let's start with question 1. I just wanted to erase what I have written here, but maybe that's fine. So today, compared to the yesterday, I wanna do extra thing. So you see this guy here, 14x minus 2x squared. You don't see. You don't see. Yeah. All right. So I'm gonna try this one. Okay, so 14x minus 2x squared minus xy. So let's write this one here. Can you help me? 14 times x.
2x squared.
What is that? Minus should where is the minus? Okay, I hope 2x
2x squared.
2x. Probably it's with this x squared
Minus xy.
minus x times y.
Yeah.
And this guy,
16.
thank you, 16 times y
Minus 2y squared.
minus 2 times y
Minus xy.
minus 2y squared minus
xy.
x times y. All right, so I'm done. Can we graph this? What is this? If I change, let's try without y at the end to make sure that it's changing. All right, so it seems that it shows only 0, 0. But it should show something else as well. All right, let's go to the question, and we can come back here again.
You need to change the min and max of x and y value.
Yeah, you are right. Thanks, mate. Okay, what do you see now? So, let's go. I will come back here. Okay, let's come. Share screen. Yeah, that's fine. Okay. Wanna see that what's the why? Maybe some items after some items we will come back there. So we wanna see that why is it linear? So I know that you know the meaning of the linearity from last week, at least. So I don't need to explain more. So this guy is here. X prime equal to this guy, y prime is equal to this guy. So let's assume that x is like in this space. This space can be L2 space or Sobolev space or whatever it is. Linear transformation or LX when we talk, it means like this matrix must be linear. It means I should have two properties. So L or one property, L of alpha times x1 plus x2. I combine them. So you see that here. So this is too much for me. I don't want to test or try this one. Instead, I will try this one. So L of alpha x, instead of this xy, I substitute this x by alpha x here, alpha y. And sticking on the principles, we can get this matrix, which won't be equal to this matrix. Alpha times Lx, alpha times this Lx. So alpha times the matrix means alpha times to the any elements of the matrix. Okay, so you see that L alpha x, I've got this alpha squared, and here I don't have alpha. Where are the problems? Problems comes from this x squared and this xy. If I had just only x power 1, y power 1, then it would be linear. So this power degree of this power of xy together is 2. Okay, so that's why there's problem here, and problem here. Anyway, so L is not linear. So to have the linearity, I should have only coefficient times x, coefficient times y. I can, and also in the second part item, it says that whether it is autonomous or not. So we know that it should be autonomous if the right-hand side or this matrix, it should have independent, or it shouldn't have T. If it does have T, then we will have then it won't be autonomous. Even so, how about the constants? Yeah, so we cannot have the constants. Otherwise, constant means actually T power 0 somehow. All right, so we shouldn't have T. So this is non-linear ODE, unfortunately. Why unfortunately? It's subjective. Yeah. So let's have a look at the critical points here. So critical points, like those points that if we sub in this matrix, like in this matrix or this here, this equation and this equation, if I sub xy, the values of xy, it should give us this guy 0 and this guy 0 as well. So that's why I will call them the first equation f1, f2. So to find the critical points, I should solve this f1 equal 0, f2 equal to be 0. Now, do you remember that in the one dimension case, we had this example, especially in your nice first assignments, the first question. Okay. All right. So it was like dy over dx, something like only in terms of y equal to be 0. So for example, y times y minus 1. So y equals 0, y equals 1. They were the critical points. So one of them was stable, one of them was unstable. Unstable means the solutions by little change of x, they were escaping from that. The stable one is the one that the solutions they were going to approach to tend to that. However, what was the here? If g prime y, which is 2y minus 1. If I have g prime 1, then it is 1, which is unstable. G prime of 0 means minus 1 less than 0 means the solutions at approaching to this y equals 0. Anyway, let's go back to this question. So to find critical points, as I said here, equals 0, equals 0. So we have this guy 0, this guy 0, this guy 0, or this guy 0. All right. To find xy, what are the values of the xy? I should use both of them. I cannot say that, okay, since x equals 0, I sub here, then find y. I should use both of them. It means like one of the zeros comes from first equation or second equation, and the other 0 comes from the other equation. X equals 0 written here. 14 minus 2x minus y is equal 0. Okay. And this one as well written here. So x equals 0, then this guy 0 or this guy 0. And if this one is 0 or this guy is 0 or this one. So I will have 4 cases. You might see slightly different in the tutorial solution. X equals 0, y, then I start with this guy, this guy. So y 0. So x equals 0 and 16 minus 2y minus x. If x equals 0 here, then 16 minus 2y equals 0. So then y will be 8. That's why I have written 8 here. Now, we analyze 2 cases. One, okay, so like this. And I wanna see this guy, okay? So 14 minus 2x minus y equals 0. So y equals 14 minus 2x. So y equals 0. 14 minus 2x minus y. So I can obtain y here. So now I'm starting y equals 0. So y equals 0. Then x will be 7 if I have from here. Hence x equals 7. So another point is this guy. And if now I have this case, which gives me y equals 14 minus 2x, and I have the last expression, okay, 16 minus 2y. So what I need is just to use this in the last expression. 16 minus 2y minus x, instead of y, I will sub this guy here. So I can obtain x equals 4. If I obtain x equals 4, I can sub in here or here, 14 minus 2 times 4. Then it will be 14 minus 8, which is 6. So I have another critical point. All right. So the meaning of this, so I have 0, 8. I've got the 0, 0 here. And can I have 4, 6? Yeah. So see this guy here. We can think about as 2 species that they, one of them is the food of the other one, prey and predator. And when there is too much prey, then, and if there is not predator, it means there is too much prey here. Why is it too much? Because there was no obstacle for them to be populated. So, and it is like this, and it is the place that humankind can intervene the process. And so a predator can fix everything. So a predator from here, when it is predator moving to this side, means the population of the prey will decrease. When there are too many predators, there is no prey. It means the food is finished. Okay, the food is finished, and there are lots of population. So because of lack of the sufficient source, they will start to decrease. In anyway, the balance ratio is this point. 4,6 is not just 4,6. It can have a unit 4,000 and 6,000, more or less. One of the PhD topics in recent years here, it was like something like this. Yeah, I missed this kind of the topics actually. So otherwise, because the university can support and you can travel over there for free, but you need to go, and not for holiday. You need to go to the bushwalking. All right, so let's remember 4,6 and 0,870. So let's go back to that Google Chrome. So it's like we restricted ourselves like to -5 +5. So that's why we were unable to see the other critical points. It was like this. So let's go there. So you see that I wish I could what? I could annotate. Anyway, can I annotate? Anyway, so there is nothing interesting here. Okay, there is no critical point here. There is critical point here at this 0, 0. There is 0, 8. There is the 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's for some reason it's attractive. Okay, this is attractive. Not attractive. 1, 2, 3, 4, 5, 6, 7. So look at the vectors. So 7, 0 is another critical point. And this should be 4, 6, is it? Yeah. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So this guy is really attractive. Okay.
Are the other two that are on the axis saddle points?
Yeah, saddle points. Let's assume that saddle points. Saddle one. Yes. So I'm gonna think about that. Can we see that saddle point? And so this time from this way is tracking, but vertically we see that it's not attractive. So we can say that it's. And how about this guy here? So this is attracting vertically, but horizontally, at least it's not attractive. But over the time, what? Something happens. Oh, see, look at this guy. So see this one. Just by chance. So, okay. Can I click on this one? This set. What was it?
7, 0.
7, 0. Yeah, 7, 0. click here. Yeah, this is really, I was not believing it's critical point. Now I believe that it is really critical point. Okay, so do you think that I should decrease this one?
Yeah. What is that, 2 or something?
To, oh, but why? Hmm. Ah, all right, so as you click, it's like, it's really good. So maybe here as well. So lengths of the variables, this guy. Oh, what's this? So we really don't like this. What is the meaning of there is density here and density here? Actually, yes, since this is not my research interest, so I cannot answer properly for this one actually, because see 0, 0, and this one. But there is like, for me, it means like proper critical points here. This is not too crowded and not too crowded, but this guy or this guy here and this guy here, it's too crowded. Can we talk about like probability of the critical points? Which one is more critical points? And maybe it's because of saddle point actually, you know. So in one direction, it's not attracting, and that's why. But however, this 0, 0, it should be like nothing. It shouldn't be attracting. Let's go back to the questions. Part C was saying to us that it's part D. We talked about the meaning of this guy. It is this. And part E tells us that please, not please, actually sketch the, which we did, but we can do it here as well. Actually, it could be better if I could code up something in SageMath, but it's, you know, I didn't have time to do that. Anyway, so assume that this is F1, F2. What you have missed for sure is multidimensional mathematical analysis. It means you know that this is F is from Rn to Rm, not necessarily linear transformation, which we have it here, this matrix, okay? The derivative of this function is not a number. Actually, in one dimension, derivative is just one number. But derivative of this from multi-dimension to the multi-channel, it's a matrix. Sometimes we call it Jacobi matrix. I also would like to call it derivative of the function, okay? So you can find this material in the chapter 9 of the baby routine, okay? Baby routine. That's a book that from you can find the chapter 9, but online, unlike the, you can find it in the library as well. There are some couple of that because it's important book, maybe the most important book in the like 50 years in mathematics. Yeah, there is and 2 weeks ago I introduced a book about the phrasing. it was like calculus or that's a very big and thick book that which has these discussions like critical points in chapter 9. And I said that it's useful for you, especially for your quiz online questions. Okay. All right. So Jacobi matrix, if you have from multi-dimension to the multi-channel, the derivative matrix will be M by N matrix. Okay. So in this case, we have F1, F2, and from 2-dimension to 2-channel function. So the matrix or derivative matrix will be this 2 by 2. So F1, F2, by knowing them and taking partial derivatives in terms of X and Y respectively, I will get this matrix. Now, what we have here, we will solve each critical point and we will obtain the corresponding matrix, derivative matrix. So what is the derivative tells us, like in the life? Rate of the change. What else? The gradient, it's increasing or decreasing. Okay, we can get some information from by derivative of the signals. Okay. All right, so at this critical point, x equals 0, y equals 0, so I will get this 14 and 16. The rest will be 0. But you guys are smart. So without asking and thinking too much, you know that the eigenvalues are 14 and 16 in diagonal matrix. Okay? And the corresponding eigenvectors will be that columns, the first column and second column. 14, 0, 0, 16. But the eigenvectors is unique up to its multiplication of that column. Means that column can be 14 times 14 and 0. And you can multiply it by 1 over 14. It will be 1 and 0. So this here. So since we have 14 and 16, xy, C1 times eigenvector, corresponding eigenvector of 14, e to the 14t and e to the 16t has been written here. And the corresponding eigenvectors are 1 and 0, 0 and 1. Yeah. So e to the 4, so x equal, so since I've got this one, x equal to e to the 14t and y equals c2 e to the 16t. And by the time, as time goes to the infinity or time passes, the x is going to the big number or y is going to the big number. It's not staying somewhere. So that's why in this here, it's really, see, the eigenvectors are the directions of the vectors from 0, 0 is escaping. Now, 0, 8 at this critical point, again, I will sub in this matrix at the critical point 0, 8. Then I will have 6, 0, minus 8, minus 16. This is a lower matrix. And again, the diagonal elements are eigenvalues. Okay. But I personally forget this. And let's, so if I try this guy, 6 minus lambda minus 60 minus lambda, you will see that we are really right. So the diagonal elements are the eigenvalues, 6 and minus 16. So Can I find the eigenvectors sticking on the principal definition you see here, and I would like to find V1, which its elements are V1, V2, 1. That's what I call. So I've got this 0, 0, -8. So from here, I did some couple of calculations for you. So you've got this one, we've got this one. So from here, V1, 1 or V2, 1. So V1, 1, V2, 1, V1, 1, V1, 1 here, -4/11. And up to multiplication is the same thing. So 11 - 4. It's possible to obtain the second eigenvector's corresponding eigenvector, which is corresponding to the eigenvalue of the -16. So I will get 0, 1. Therefore, x, y is this guy, e to the 60 and e to the -16t. So since x equal to C1, have a look at here. First row, C1, 11x1 exponential of 60. Y is this guy at C2. When let's assume that C2 is 0. This is nothing. So so x will be C1 and y is this guy here. From there, y over x minus this guy. So that's why we've got this one. So it is this guy. This line, actually, I get this line here. And the directions are obvious. And the directions are obvious why it is like this. Because these +6 and +6, it's escaping. So if I've got, can I have, let's assume that C1 is this one. So C2 was 0, C1 is 0. So let's assume that C1 is 0. Therefore, x is 0. Okay, x. So we, at this point, this is 0, 8. We don't go not to this direction, not to this. We don't move. We are in this line. So y is C2 - 16. So that's why this, because of this one, I've got this one here. So the direction is y because of this -16. Now you've got this guy, and this guy, this guy. So you are able to know that what's happening here. Can we have different directions? No. Otherwise, critical points will, this is not critical points. If this is changing, contradiction. If this is changing, therefore, you can say that, okay, there might be different critical points here. Okay. Nevertheless, second reason to plot these things is assuming that C1 is equal, not equal 0, C2 is not equal. So 3 cases. Okay. Yeah.
How did you get V2?
V.
Eigenvector.
I just didn't calculate it. I just at home I calculated. I just wrote it here. Yeah.
You get the matrix of 22, 0, -8 and 0. So,
What?
well, just in terms of if you calculate it rather than knowing.
Which one are you talking?
For the second for the eigenvector associated with the eigenvalue.
What's this?
V2, 0, 1.
Yeah. So do you have any idea about this V2?
I got 0, 1. So just chuck in the eigenvalue of -16 and you get the matrix of 22, 0, -8, 0. So then.
So it's not compatible. So
no, I think
it's the right.
Yeah.
Okay.
So.
All right. Okay. I thought that you want to say that. And 0, 1. Software or I just calculate. So I didn't say this one like suddenly. Is there any like remark to doing this fast? No. Okay, so I need to calculate it, but I just didn't want to write.
Okay, so what, how do you calculate?
It's like previous, like the previous one. See, this time A
Oh, because lambda equals 6 or 16.
A V2, yeah. Minus 16 V2.
Okay.
Do you want me to write the rest?
No, that should be right.
Oh, okay. So I didn't say it like there is a remark and we can just say it or we can write it quickly. No. All right. So this is so we said C2 is 0, C1 is 0. Okay, let's see that what happens. C1 is not 0, C2 is not 0. So y over x minus so y is this guy. So I wanna divide y by x, means divide this right hand side by this right hand side is here. So we've got this one. Okay. So from here let me see. And this should be actually this should be 620 20. All right, so we've got this one, okay, and then after y equal to something times x. So I don't remember how I can conclude from here to these guys. But however, we have two reasons. So one reason is this. By using this yellow and red color, you can say that the directions of these guys, okay? But the second reason should come from this guy. So C2 equals 0 gives me this yellow, but C2 non-zero actually yeah. Y over X. Yeah, just don't I don't have any idea. Okay, anyway. All right. Anyway, so let's have a look at quickly the other 0 8. 0 8, where was it? Yeah, here. So see, there is a straight line here. Okay, almost. And these guys are like this one, and there should be something like here as well. So there is this guy as well. So more or less it looks like what we have in handwritings. What happens the other critical points? You can do it and you will see it in the tutorial solution. Part F, you see this guy here. Xt is going to the infinity and y goes to the infinity. What will happen in the reality? So let's see this guy here. You see. Okay. So let's assume that x is infinity. Okay. So minus infinity minus infinity. X infinity, y infinity is positive animal. So times minus, and there is infinity times -2, it will be, so together these guys, we don't care about this 14 times x because this 14 times x is weaker than compared these two guys. So it means if x goes to the infinity, the whole things will be negative infinity, negative animal. So this means, let's assume that x and y, they are together is infinity. One of them, x tends to the infinity. This means x prime is less than 0. X, y positive together minus infinity. Y is positive together is minus infinity. But x, if x is going to the infinity here, the whole line, the whole equation, the value will be negative animal. So this will be y prime is less than 0. X prime is also less than 0. What does that mean? If one of the species tending to the be populated, then everything will start to decrease. X prime will start to, x prime is negative, so it means we will have rate of the population will be negative, and y prime will be also negative. All right. So the same thing happening if you assume that what happens when y goes to the infinity. So there is a between x and y, like on these equations there is harmonicity. So xy, so again this x prime y prime will be less than 0. All right. F, using the information in your local phase plane diagram in E, sketch a global picture. So which we did. So this is this part G, probably it's part G. Part H, assume that each population is initially positive. So what happens if t tends to the infinity? So by the time, so what happens to that? I believe that pardon?
You just go to 460.
With higher probability, yes. But something could happen because we got at saddle point or at weak attraction point, critical points as well. 0870. Because of like hunting one of the species too much. Okay. So this could happen to this one, or is predator or can eat other sources. Something could happen, but the higher probability 4-6 is strong attractive, but the 70 or 08 is the see this guy here. 08, there is attraction here, although there is not attraction in the horizontally as well. All right. Okay. Where was this link? I got it actually. This link, you can find it in the previous week's handwritings. Here. It is the first, this guy here. That's this link. I'm not, so I don't remember what this one is, but you can maybe, since it was, maybe it was useful, that's why I put it here. Okay. All right, so next week, okay, I doubt if you put, if you see these types of questions, the final exam, but the final exam number 1, the practice test has been released. So it will be like this. The practice test for the final exam has been released. Second, if we finish next week sooner, we can do practice test. We can solve some of them, which I would like to do that. All right, let's end this session. Okay.